Now heading toward the next section. So file system operations. So there are various operations we perform on by file system. So usually we say that the file system is the one which manages whole of the content. Even it stores the operating system itself. So the sequence is whenever we boot our machine, so the bootloader loads the kernel from the secondary storage and it start running, and then it brings it into the main memory, and from there the all the processes would start one by one, and whatever applications you have initiated and created, like it should start at the boot time, so all those applications would start, and one by one they will come into the main memory and allocated to CPU. So our secondary storage is the main thing, and the file system is managing all those files, including operating system files or user related files. So everything is being managed. So for that, there are different data structures that has to be managed onto secondary storage, because as we discussed in the previous slides that operating system or the main file system resides onto the secondary storage. And there would be some data structures those are required for this file system to work onto the in memory or the main memory, also the physical memory. So for on storage, the file system may contain information about how to boot an operating system, total number of blocks, the number of location of free blocks, the directory structure, individual file. So all that information would be included and put onto the storage, the secondary storage. There are few data structure. One is the boot control block. So this is also very important block, which is onto the secondary storage and contains information needed by the system to boot operating system from that volume. So usually it is the first block of the volume, so that this is one thing. And in different operating system we call it different thing, but in NTFS we call it as a partition boot sector. There is another block which is called volume control block, also called super block or the master file table, that contains the volume that contains the volume details, the total number of blocks in the volume, the size of the block, the free block count, and the free block pointers, and a free FCB count and the FCB pointer. So this basically hold as a master record of the all the information of all the blocks which are there. So any process requires any storage, they can it can come to this particular block and then pick the information. It also we require a directory structure. So directory structure, how the files are in organized, and the metadata about that structure. So the names in nodes, inodes number, and your master file table, and it is in an NTFS system, it is stored in the master file table. So we call this as a master file table. So for per file, so whenever you create a file, so as we know that in Linux, uh, uh, everything is a file. So whether it is a directory, whether it is a device, or it's actually a file, so all are treated as files. So per file, a file control block is maintained. So that contains the information about inode number, permissions, size, dates. So all these information is actually recorded, and this is the metadata of the file. So it's data about the file, what permissions we have when it is created, who is the owner, what is the file size, file data blocks, and pointer to that file data block. So this whole information is in a package. So whenever a process started working on a file, so this would also be updated or fetched, because this contain every information about the file. So we see when the last file is updated, who is the owner of that file. So all that comes from this FCB metadata, which is per file. So remember, this is per file record. There are some structures in for in-memory file system structures. So first is the file mount table. So mount table is that stores the information about the mounts, the mount points, the file system types. So all that information is there. So if you guys have worked with the little older, like 4 5 years earlier on Linux system, then there was the NTFS system was not supported, and we have to install different modules to mount NTFS file system onto Linux operating system. So nowadays it is seamlessly coming, all drivers are there. So file system mount points are basically what you are mounting as an as your hard disk or your USB or anything else. So what mount point you give, slash J colon slash or C, all these are could be called as an mount point. So slash, so backslash is the one which is a root directory mount point. So how you are mounting all those hard disks on, and where the information is stored, that is kept into mount table, which is an in-memory data structure. So in-memory data structure cache holds the directory information of recently accessed directories, and this would actually help to make the process efficient. Then we have system-wide open file table. So this is another data structure which is kept, and it is very important because every information, every file that is currently open on the operating system would be kept into this system. It contains the copy of FCB for each open file, as well as other information related to accessing that file from the secondary storage. So then we have per process open file table. So for each process we have uh, a pointer, that per process file open file table that contains pointer to appropriate entries in the system wide file table. So this actually points to this, because the system wide includes information of all the files those are opening. And then we have per process open file table. So this process requires some files to be opened, and then what it contains are pointers to the appropriate entries in the system wide open file table. So this is kind of another level which is given, but per process is open file table is individual and unique to each and every process. Then there are buffers to hold system file blocks when they are being read from or to return to the file system. So here is a diagram that explains it. So whenever a user wants to open a file, a new file, it is a new file or an existing file. So from the user space, the directory structure would be looked into. If it finds where what is in the directory structure, we have system wide open file table. So if we find the entry of that file, then it is good. Otherwise, what is done is it would be allocated to it would be a data block. The directory structure would be actually capturing some data block from the memory, and it will be connecting here, and then it will allocate the profile control block to that newly created file. So if this is this is new file, if we are reading an existing file, so what is done, the first it'll try to index the per process open file table, and if it finds the index, then it is basically trying to search for the system wide open table, and the system wide open table would contain the entry for that particular file, which will bring the data blocks and also fetch the file control block for that particular file. So this per process open file table would be used to point towards the system wide open file table, which contain the information of each and every file onto the secondary storage, and also contain information about the file control block of that particular file. So this is how by using these two data structure in memory, each and every file is being managed, updated, and the data is being retrieved for those files. So usage is whenever an open call is there. So a call passes a file name to the logical file system. Open system call first searches the system-wide open file table to see if the file is already in use by another process. If it is a per process, open file table entry is created pointing to the existing system-wide open file table. So whenever it is already there, so per process open file table creates an pointer to that particular location. If the file is not already open, the directory structure is searched for a given file name. Once file is found, the FCB is copied to the system-wide open file table. So this is basically managing all those files which are open. So as we are opening new files, so new file information would be updated into this system-wide open file. So this system-wide is used because there maybe the processes with more than one processes want to use the same file. So when a process is closes a file, the per process table entry is removed and the system wide entry open count is decremented. So because that also holds a count for how many files are currently accessing this file, so that count would be decremented when all the user that have opened the file close it. Any updated metadata and copied back to the disk based on directory structure, and system wide open file system entry is removed. So when all the users which are accessing that particular file closes and or terminated or ends, so that then the entry from the system wide table open file table would also be removed. This is so there are different data structures managed to hold the information about the file, how to bring the data from the secondary storage, and then managing and updating FCB. So there are different data structures, those are used here.